see if we can actually remove those without accidentally removing any more. If we remove half a dozen, it's going to be so simple to actually replace them, it's not really a problem. So that's just, I'll use the microscope to use the polish, put it down the microscope. So I have one problem here. Okay.
Itu ada pulau, nggak mau ke pulau. Nggak mau ke pulau. Oh, ya.
Ada itu dayu.
Ambil daun banyak-banyak sih, daun tuh susah.
Pulau berikutnya aja deh makan.
I'll get some foots on.
Bikin pancingan.
Biar bisa mancing ikan. Biar bisa mancing guys, biar bisa makan.
But again, we seem to have a problem with delamination of the substrate, and this appears to be the problem with this method. It's not getting enough heat into the job that's the problem. Once you have a preheater, it's getting enough heat into it evenly. That's where it seems to be going. It seems to be wrong. But we can try. What the hell? Why not? First thing, let's
Wait, ini belum ngebuat.
Let's see if we can see what it does or doesn't do. So
I don't have any rope, what the hell? Nah, sip. I need building hammer and I need plank.
Well, we have a short. So all the actually this achievements the GPU is that short.
Bagus lah, banyak barrel.
Yeah. So guys, I think this last
Boleh.
Can we replace the BGA with this sort of equipment? And the answer is no. Unless maybe you've got extremely lucky, or maybe you just better at doing the job than I am. I have to say no. I think it may be possible with an alteration to the equipment.
Kurang plastik nih.
Kalau mau makan bilang deh.
Nih plastik nih. Nih plastik.
This is getting enough heat evenly into the job to be able to remove the GPU without effectively causing the GPU to
kurang daun.
Oke. Daun agak susah nih, udah mulai susah nih daun.
170 with the process here, which of course depends on where you are. The Canary Islands. And you can buy them for about 160 with the process I've seen. Or even maybe just, effectively a hot plate out of the kitchen. Yeah, something like that, a griddle or something, maybe.
Ombak ini
Ombaknya
But this is
kegedean.
28 by 27 centimeters, so it's quite big, probably big enough for a motherboard. 1600 watts, or no, 1500 watts of heating. I think something like this, if you can actually get the temperature up high enough on the board before you start to use the hot air, you may have a chance to do it. And at the end of the day, my VGA station has something like this with hot air above and below. So hot air can do the job, it's just a matter of getting an even distribution of heat into the job. Okay guys, I'm not sure what you expected when we started the experiment. This is pretty much what I did expect, because I have tried to do this before, and this is what happens every time, to be honest. But if you've got any suggestions of something no more expensive,
Ngok.
Udah aku buat storage-nya.
Oke.
Ada makanan.
Heeh. Aku mau buat fishing rod juga lah. Butuh 2 lagi.
I place the power switch on front panel jack. For power switch, it does not matter which end, positive or negative, is connected to which end, positive or negative, on the motherboard. Its task is to just connect and disconnect the power.
Kamu tahu nggak? No,
And here is an LED
Kenapa?
adapter from
lagu
strap
ada
motherboard as
yang
well.
sewa itu.
Iya, lagi
The
ini
LED
lagi
light
ngetren.
is recorded. Its positive end needs to connect to positive end
Iya.
on the motherboard and its
Yang
negative
nyanyi
to negative end.
ada yang kayak nyanyi
I
dari
plug in the
kindergarten.
LED as well.
What the hell?
I use a buzzer as well. Buzzer helps you a lot in troubleshooting.
Set.
I place it on the next front panel
Kan
jack.
ada nyanyinya kan kayak nyanyi rock.
Every motherboard's front panel
Yang
jack
lagi
is
viral
different.
dia nggak nyanyi pakai
Some of them are split and some are not split. This motherboard has a buzzer itself.
Gara-gara suara
Instead
kayak
of
anak-anak
placing
kali.
the second buzzer,
Wah,
I can just
mabar.
use
Iya,
motherboard
Kak.
with one
Aku
buzzer.
lagi mabar,
I
Kak.
place the second buzzer anyways because it is my routine. So, the first voltage that is present on the motherboard is the voltage provided for motherboard by this battery.
ini kita
Usually it is
mulai
A plus
ya.
3 volts,
Hah? Oke.
which enters PCH and a part of I/O,
Ini sudah disebut.
and drives a part of this
Ke
PCH.
pulau ya?
I'll check the voltage on the motherboard and show it to you.
Kurang ajar.
Anjay.
Ini gimana benerinnya?
Siok.
Yes,
Siok.
around 2.9 volts is
Ini gimana
present.
benerin ya? Nggak bisa dibenerin
One
loh.
important thing about most motherboards is that
Jadi dia nggak bisa bener.
CMOS settings on the motherboard
Dia
may have
tunggu
problems.
hancur.
Oh, ini bisa, Deng?
In such situations,
Dah.
the first thing I need to do is to
Bisa ya?
remove the battery
Bisa.
from
Jadi dia di
motherboard.
scroll.
Jai.
Jadi kan pegang hammernya, terus diklik di tahan kanan.
There is
Itu
usually
ada
a clear
dia
CMOS jack.
ada gambar palu plus.
To clear CMOS,
Nah, itu
I
tak
connect the
pencet
pins of
kanannya
clear
ditahan.
CMOS jack to each other, or I can connect positive and negative end of the battery to each other. There is a 32K crystal in here.
Oh,
Some
aku
repairmen
dari
connect the
kemarin
pins
main
of the
ini
crystal to each other,
kayak nggak bisa memperbaiki Raftku.
so that the problem of the device which does not turn on, or the
Iya.
device which does not have display.
Kalau di Raft nggak bisa benerin, udah lah nggak usah main gitu mah.
2K crystal in
Susah
here.
bener
Some
mainnya.
repairmen connect- There is usually a clear CMOS jack. To clear CMOS, I connect the pins of clear CMOS jack to each other, or I can connect positive and negative end of the battery to each other. There is a 32K crystal in here. Some repairmen connect the pins of the crystal to each other, so that the problem of the device which does not turn on,
Aku
or
butuh
the
lift.
device which do not
Ada
have
nggak
display,
Lift,
will be
aku ada
solved by
4.
clearing the CMOS.
Daun.
Nih.
I clear the CMOS. I place the battery now.
Nih.
Miris sekali ini nggak ada
The
lift.
battery provides voltage of a part of PCA,
Tersiksa bener aja.
as well as voltage of
Terus
this
apa
crystal.
lagi? Jauh banget.
Let me show the voltages on the pins of this crystal. Around 230 milliamperes is present on this pin, and 377 milliamperes is present on the other pin. So this shows that voltage is present on the crystal. And most probably its clock is working. Let me show you the clock. Its voltage of a part of PCA.
What the hell, perkara ombak doang nggak bisa ngambil.
This crystal.
Ah,
Let me show the voltages on the pins of this crystal. Around Around 230 milliamperes is
Oke,
present on
dapat.
this pin. And 377 milliamperes is present on the other pin.
Finally.
So this shows that voltage is present on the crystal. And most probably its clock is working.
Oh,
Let me show you the clock.
astaga salah lihat saya.
Hah?
Karena aku mau apa nge-craft research table.
Ah,
Ya aku pencet malah simple bed.
Yes.
ya ampun. Mau bikin
Jadi bahan
ya sudahlah.
kamu ada
As
scrap
you see,
buat
if I press the auto button,
Scrap aku ada 6.
around
Nih.
32 kilohertz. Crystal frequency is 32.770 kilohertz. It's in fact 32.768. This shows that crystal is working normally. So no power is connected to motherboard yet. Voltage is present on crystal pins, and its clock is working. Before I connect power supply to motherboard and switch it on, let me give you some info about power supply functions.
thank you.
Nyoi.
Power supply will be
Bosannya
switched on.
sini.
When
Iya,
power supply
harus.
switches on, power grid voltage, the gray wire, would increase to plus 5 volts. Let me check and show the voltages. First I check voltage of purple wire.
Ini kita harus buat sale nggak sih?
The same voltage plus 5 VSD is present on the green wire
Buat
as well,
sale
which is the
biar
PSO.
dia ketiup angin tuh lebih cepet jalannya.
And no voltage is present on
Oke.
the gray wire right now.
Boleh.
We need palm leaf 20, scrapnya 3.
Yes.
Ini palm leaf nih, nih, palm leaf nih. Nih. Ah,
Power grid voltage
Ah,
from the
itu.
gray wire would enter the motherboard from power supply.
Aku yang
iya buat sale-nya.
I switch on power supply.
kekurangan.
Yes, plus 5 volts
Kekurangan
is
apa?
present on the gray wire now. Plus 3 volts, plus 5 volts, plus 12 volts and minus 12 volts would enter motherboard through power supply. So you learned about power supply
Kekurangan apa?
I'll continue troubleshooting of the motherboard now. By switching on the power supply switch,
Tuh
plus
ada
5 VSD enters motherboard through
aku
purple wire.
kekurangan plank
And
dulu.
after passing the regulator IC, the regulator generates plus 3 VSD.
Kekurangan
Those
planknya.
voltages enter PCH and I/O. First, I/O gets reset. When I/O is reset, it sends RSMRSD signal to
Ah ini
PCH.
plank nih di belakang.
And it resets PCH.
Ini plank semua.
Motherboard is ready. When I switch on,
Butuh berapa
Banyak
lagi?
banget.
Iya, dari
Udah
tadi
ada.
ngambil terus.
I/O detects that power is switched on. And it sends power button signal
Anchor
to
nggak sih, anchor?
PCH.
Anchor cuma sekali pakai loh.
In response to I/O,
Anchor sekali pakai.
so you learned about power supply functions.
Supaya
I'll
berhenti
continue
maksudnya.
troubleshooting of the motherboard now. By switching on the power supply switch,
Oh, nggak ada.
plus 5 VSD enters motherboard through purple wire. And after passing the regulator IC, the regulator generates plus 3 VSD. Those voltages enter PCH and I/O.
Jalan.
Now,
Aku juga pengen makan.
motherboard now. By switching on the power supply switch, plus 5 VSD enters motherboard through purple wire.
Oke, aku akan memancing untuk biar kita bisa mendapatkan ikan.
And after passing the regulator IC, the
Ayang itu biar
regulator generates plus 3 VSD. Those voltages enter PCH and I/O. First, I/O gets reset. When I/O is reset, it sends RSMRSD signal to PCH,
mesti buat itu nggak sih?
and it
Kapak.
resets PCH.
Kapak, iya.
Motherboard is ready. When I switch on, I/O detects that power is switched on, and it sends power button signal to PCH. In response to I/O, PCH transfers
Kekurangan
SLPS4
plank.
and SLPS3
Berapa kurang
Kamu
berapa?
aja deh, Rin. Yang
And when I/O receives
Ngapok-ngapok.
SLPS3,
Oh iya dah,
Increases PSON
Aku
voltage
ngapak-ngapak.
to 0 and plus 5 volts.
dah aku udah buat.
The green wire drops to 0.
Ini berhentinya gimana?
Ini biarin aja, ini kan karena ada
nggak
sale
pakai
kan.
enter.
And motherboard turns on.
Ini biarin, ini kan ada
This is how the
sale.
motherboard turns on.
Biar ketahan aja.
Heeh.
As this motherboard is damaged. When I switched on the board, it turned on for a second and turned off again. Because settings are saved on CMOS. I should switch the power off and reset BIOS settings.
Beb, kamu Genshin udah nyampe jauh belum ada konvensnya belum? Sebenarnya ada mekaniknya dengan rompau, seneng banget. Belom.
I reset BIOS in this way. OR by constant clicking of the power switch button. I place the battery. I switch on power supply again.
Mi, kayaknya kita perlu storage banyak kan deh.
Turned on for a second and then turned off again. As I told you in previous
Banyak ya?
video, this shows a short circuit in the motherboard.
Storage.
So let's check the power block of the motherboard on the board view. At first, plus 5 BSD enters motherboard through ATX jack. And along with plus 5 BSD, power supply on PSON enters motherboard I/O as well.
Aku kehausan,
I/O can control the power supply and turn it on or
Kamu
off.
udah nge-craft itu
Udah minuman?
I'll check plus 5 BSD on ATX jack.
kan?
Iya.
It enters different blocks. It enters this MOSFET Q23 in here.
Ada plastik nggak bro?
Plastik.
Mau memperluas lahan nih.
Oh, 17 nih.
Anjay.
Which is a double MOSFET. It is made up of AP channel and
Luas
an N channel
lahan tapi
MOSFET.
kayunya juga.
It has 2 inputs and 1 output. The drain pins of these 2 MOSFETs are connected to each other.
Oke, ini kita
Luas lahan belakang atau kesini?
Output can be
sebentar,
either
kayaknya aku masih mau
or an
farming deh.
N-channel MOSFETs. It enters power supply and turn it on or off. I'll check plus 5 DSD on ATX jack.
Apa sih?
It enters different blocks. It enters this MOSFET Q23 in here, which is a double MOSFET. It is made up of AP channel and an N channel MOSFET. It has 2 inputs and 1 output. The drain pins of these 2 MOSFETs are connected to each other.
Oh, minder. Oke.
Coba sebentar, aku mau naruh-naruh
Output can
lagi
be either of
barang.
these inputs.
Aku mau naruh ini.
I explained about this type of MOSFET in previous videos. Here, 2 MOSFETs are placed in one IC. The upper MOSFET is AP channel MOSFET, which transfers plus 5 DSB to the system. And the lower MOSFET is an N channel MOSFET, which transfers plus 5 volt switch VCC5 to the motherboard. To control which one of these plus 5 volts should enter system, their gates need to be controlled. Their gate is controlled by an IC U19 in here. When the system is on sleep mode, switch voltages get disconnected, and this IC U19 reads gate of this MOSFET Q23, and it causes plus 5 DSB to enter 5 PDIMM RAM VCC. And it causes plus 5 DSB to enter 5 PDIMM
Boleh,
RAM
boleh,
VCC.
pindah.
And when I switch on the system, this controller IC U19 reads gate of lower MOSFET, which is an N channel MOSFET. And this key gets closed connected, and plus 5 volt switch VCC5 will be present in here. Plus 5 volt
Tempat
switch
kita
and
sangat
PWM of RAM VCC
Sangat-sangat
and
sempit
capacitive
sekali.
conductor. And 1.5 volts of RAM VCC will be present on this choke inductor. 1.5 volts of RAM VCC is generated by this PWM U14 in here, as well as by these 2 N-channel MOSFETs. I explained how to test these MOSFETs in previous videos.
Walah, oke sih. Terus Tonomin juga ada ngomong di sini nih, ih gile. Oke deh.
The next sub-voltage
Udah
is
selesai, Ren.
VDDR, which is
Ada.
generated from 1.5 volts
Udah
of
tinggal
brand
kalau mau
VCC.
mancing tinggal
The
mancing.
next sub-voltage is VTT-VDR, which is generated from 1.5 volts
Aku
of brand
mancing lah
VCC,
biar ini kita
which
punya
generates
resource
half of
banyak makanan.
1.5 volts of brand VCC. By the help of a regulator, which is generated in switched mode. Pin 1 as its input, pin 4 is output of regulator. This voltage is present on pins
Sebenarnya udah
120 and 240 of
Kulkas.
brand block,
Aja pakai ini.
although voltage would be in switched mode. So, brand VCC is in this block.
Bro, kalau punya kayu minta dong kayu.
Kayu
Brand VCC
banyak, mau berapa? 40? 48 aku punya.
Mau memperluas lahan kira-kira
Nih,
berapa?
20.
I don't have much to do with this block for now. I was checking to which blocks plus 5 DSB engine. This is RAM VCC block, which is checked completely. In the next block, plus 5 DSB enters another MOSFET, which is AP channel MOSFET 228. The IC number is written in here. I know it's AP channel MOSFET by looking at the IC number.
Oh, berarti kalau banyak apa namanya? Ada banyak daun, berarti kita deket sama pulau berarti. Nah, itu ada pulau lagi di situ.
Kenapa, Ren?
Kalau ada banyak daun, berarti kita deket sama pulau, Itu di depan ada pulau lagi tuh di depan.
Aku selama main ini tidak akan
UP7706 regulator plus 3 DSB will be
Ini
present
kalau
on
aku
output of
remote
this
bisa aku
regulator.
pindahin kan ya?
Apanya?
I need to test input and output of this regulator,
Oh iya, bisa sih dipindahin.
as well as test the
Gitu,
input
kan.
and output pins to each other
Soalnya,
to see if the regulator is shorted or not.
anjir.
So,
Masuk,
after I tested this block,
masuk dia.
plus 5 DSB enters another double MOSFET here. It is similar to the double MOSFET above. It is made up of 2 P channel and N channel MOSFETs.
Oke, open.
Drains of the 2 MOSFETs are connected to each
Ke
other,
sana. Jalanlah kamu ke sana.
and plus 5 volts of USB is present on its output. And in here, to be able to control which one of MOSFETs to be connected. Meaning, which of these keys to be closed
Walau
connected.
nggak nyampe.
You need to control them through their gate pins. The gate pin of these MOSFETs are controlled directly by I/O.
Hanya kecil tapi itu.
Although in here, plus 12 volt switch enters MOSFET Q27 directly, in case I/O wanted to protect the circuit. And there was a short circuit. Gate pin of MOSFET gets led by this transistor Q70 and it's gated also by I/O. Its drain connects to its source, which is the GND, and voltage drops and MOSFET gets disconnected. In the next step, I check switch voltages. The first switch voltage to be checked is plus 3 volt switch. It enters different
Kok
blocks.
suara Furina ini kayak Yamato ya? Sama ya ngisi suara.
I/O, PCI slots, PCI Express and RAM slot. 1.8 volt CPU is provided by plus 3 volt switch, which is generated by a MOSFET and an op-amp.
Kamu nambah tempat lagi ya, Ren?
Iya, aku nambahin agak kesinian.
Pengisian.
It is a dual op-amp. I use this section. Pins
Dan aku
1,
sekarang butuh
2,
plastik.
and 3 are used. Pin 2 is
Ini aku
source
ada
pin
4
MOSFET.
tapi cuma 4.
Ayo, yaudah nggak apa-apa. Aku. Walau weh, hampir
Pin 1
jatuh.
is gate pin of MOSFET.
Udah.
Belum itu.
Udah aku ambil.
Belum lah. Oke.
Udah aku ambil.
Siap.
Siok ya.
MOSFET output, source pin, enters pin 2. It gets compared with pin 3, which is 1.8 volts. If MOSFET output voltage is lower than 1.8 volts, output will be high. Gate of MOSFET 260 gets led, and voltage enters to source through drain, and gets stabilized on this capacitor EC37, as long as this voltage is lower than 1.8 volts. The voltage will be present on this capacitor. If this voltage is higher than 1.8 volts, it gets compared with pin 3 in here. As a result, output gets low. Gate voltage will be low and MOSFET will be disconnected. And voltage of this capacitor will be lowered over time. And with constant connection and disconnection, 1.8 volts will be fixed on EC37 capacitor. So I have checked this sub-voltage as well. The next main voltage that I'll check is plus 5 volt switch. Plus 5 volt switch enters RAM VCC 223.
Ke situ, Ge, masa nggak bisa ke sana?
Anchor nggak sih?
Anchor. Wah, sayang sih cuma sekali pakai masalahnya. Mending beli pedal.
Apa?
Mending anuin pedal.
Ini berhenti. Pedal.
Ya, nggak ada angin ini berarti.
Ya.
Nggak ada plastik lagi, kurang ajar.
1.05 volts PCH VCC gets generated from plus 12
Aku
volt
getter
switch.
plastik dulu.
Switch 1.05 volts is generated by
Aku getter
MOSFET
plastik
and
dulu.
you see the
Udah kalau gitu
PWM
jangan di
here.
sini dulu aja.
Ada di
Gak usah
situ.
di sini dulu.
Ya udah. Oke, di situ ada
Kita di
dulu.
pulau lain.
Now I need to check voltage on ATX
Okay,
jack
okay.
power 2 JPWR2, which is CPU VCC voltage.
Kita open, tapi ngarahnya ke arah sana.
I can check them one by one on these chokes. For example, I have CPU GFX4 on this choke, which is generated by this PWM and this MOSFET.
Jangan itu lihat-lihat, jangan dari.
I can check these MOSFETs one by one and make sure that they are okay. I can check their ohm on this choke.
Masa iya? Wah gila, aktris mahal.
The next
Iya,
voltage is
aktris
CPU
mahal.
voltage, VCCP. One of its phases is generated by this PWM U4 and these MOSFETs. And its other phases are generated by PWM U1 and its MOSFETs. I can check these low MOSFETs and
Minggir
PWM
kamu.
U1 itself by
Minggir
performing a check
kamu.
on this choke. And check high MOSFETs separately. I have checked PWM so many times. Next voltage to be checked is on choke 10.
Kenapa?
It is CPU VTT voltage.
Raufis kumak.
CPU VTT is generated by this PWM U29 and its MOSFETs.
Itu burung arah
Mentah
I can
kemakan.
check this very
ikan
easily.
mentah kemakan siap.
Kenapa?
Ini burung nih, lihat ke atas nih. Burung ini arahnya pergi ke sono, berarti situ ada darat. Daratnya balik lagi ke sana. Iya. It's the basic survival instinct in ocean.
Okay.
I
don't have it.
Well, now you know.
More you know.
Ah, ya sekarang kan tahu berarti kalau misalnya amit-amit nah kan. Berarti pertanda ada deket beb, udah midnight beb. Buset. Iya, heeh.
I want to check power block of motherboard. I remove CPU. First I check ATX jack. Plus 3 volt switch is present there. Around 20 ohm appears on this way. If high ohm appears on one way, you don't need to perform ohm check on the other way. Good ohm appears on plus 5 volt switch as
Ke
well.
bunga atau
Good
kemana
ohm
ya?
appears on
Small
plus 12
crop
volt
itu
switch
iya
as well.
kayaknya.
Ini bunga-bunga ini
High ohm also
berguna untuk
appears on
apa?
plus 5 VSD.
Buah-buah itu bisa ditanam lagi. Ditanam lagi juga bisa.
Apa, Ren?
Ditanam, dimakan juga bisa.
I want to check power block of motherboard. I remove CPU. First I check ATX jack. Plus 3 volt switch is present there. Around 20 ohm appears on this way.
Oh. Manja ini. Mesti fresh
High ohm
water.
appears on one way. You don't need to
Iya
perform
dong.
ohm check on the other way. Good ohm appears on plus 5 volt switch as well.
Ah, pancinganku.
Kalau bunga-bunga itu biasanya untuk pewarna.
Ion also appears on +5 VSD.
Kenapa, Ren?
Kalau bunga itu untuk pewarna.
Oh. Warna apaan? Tidak berguna.
Biasanya dia ada nge-crafting apa gitu, dia pakai warna, pakai bunga itu.
Oh, biar bagus.
Atau enggak emang desainnya begitu.
Oh.
Ion appears on
Oke,
one
look
way.
out for island. Kayaknya kita deket sama island lagi deh.
Oke.
Appears on this way.
Ren. Aku butuh fishing rod.
Ion appears on one way. You don't
Oh,
need
yang
to perform
keluar.
a check on the other way. Good on appears on +5 volt switch as well.
Atau
Good
enggak
on
sama
appears on +12 volt switch as well. Ion
Enggak.
also appears on +5
Kumpulin.
VSD. The bone does not appear on one way. I need to perform a check on the other way to make sure. The bone does not appear
Hal-hal
on one way.
terbodoh lagi-lagi
I
makan
need to
ikan
perform a check.
ikan mentah.
The bone does not appear on one way. I need to perform a check on the other way to make
Makan
sure
yang-
that there is no
Iya, yang
disconnection or
mentah.
short circuit.
Bodoh banget
By
teman.
performing home check on the other way, and if home
Lebih-
appears there, you can make sure that there is no disconnect. As you see, good home appears here. And there is no disconnection or short circuit. Here I perform home check on -12 volts. Usually home does not appear on -12 volts. I can perform home check on both ways of -12 volts. Yes. Power supply on PSON signal is not shorted. Power supply. I can perform. Oh, volts.
Aku butuh
Usually home does not appear
makan.
on circuit. Here I perform home check on -12 volts.
Butuh makan.
Usually home does not appear on -12 volts.
Udah
I
ada
can
makan.
perform home check on both ways
Oh,
of
okay.
-12 volts. Yes. Power supply on PSON signal is not shorted. And it is not disconnected as well. I check all of PWR OK signal. This is okay as well. +12 volt CPU is left to be checked. Yes. This is okay. PWMs and MOSFETs that generate the voltage of sub-voltages are left to be checked. So I start from the top. This double MOSFET generates +5 volts RAM VCC.
Alright.
It comes from two directions. I explained them before. High ohm needs to appear on this way on P-channel MOSFET. And low ohm on the other way.
Waduh, barangnya tinggal dikit nih.
Yes. Lower MOSFET is an N-channel 1.
Kenapa?
Low ohm appears on this way.
Nggak ada barrel ya?
High ohm on the
Bukan
other way.
nightmare aja gitu. Barang tinggal
This shows
dikit.
that MOSFET is not shorted or disconnected. Here I have PWM of 1.5 volts of RAM VCC. Drain of this MOSFET is connected on this choke.
Tuli.
I can perform home check on drain to GND. And make sure consumer, PWM,
Oh, ini nggak mau buat simple bed, jadi kalau ini tinggal tidur.
and make sure consumer,
Kalau udah malam.
PWM and low MOSFET are okay.
Butuh nail.
And make sure
Tapi aku
consumer,
ada
PWM and
Sabar,
low
aku
MOSFET
buatin.
are okay. So let me perform
Nail,
home check
nail,
on
aku
drain.
udah nail.
Aku udah buat.
Here. I perform home check on the other way. No home needs to appear here. Yes. So this shows that low MOSFET, 1.5 volts consumer, and PWM don't have problems. Only the high MOSFET is left to be checked. High
Huh?
MOSFET is an N-channel 1. Let me check that as
Eh,
well.
supaya
Low home
kelihatan ya.
appears on one way,
Hah?
and high home appears on the other way.
Anjay.
Nggak bisa tidur tapi
So,
lagi
high
siang.
MOSFET is okay as well. 1.5
Wah,
volts
wah,
of RAM
pulau,
VCC
pulau,
is
pulau,
okay.
pulau, pulau.
PTTDDR generator regulator is left to be checked. Its pin one is input of 1.5 volts.
Pulaunya gede banget lagi.
Itu gede tuh.
Makanya.
Anjay.
I already performed home check on it. It is okay on this
Tapi
way.
untuk saat ini kita sebenarnya nggak
I performed home check on its pin 4 output.
Hah?
It is okay too.
kita sebenarnya nggak butuh bunga dulu nggak?
I perform home check on both ways.
Iya emang.
I need to perform home check on input to output to make sure there is no short circuit inside.
Wah,
Woi.
ada hewan-hewan yang
I check RAM VCC.
Iya yang ngebunuh gitu.
Here I have a MOSFET which connects and disconnects plus 5 ESD by I/O. Let me check this MOSFET, which is AP channel 1.
makan buahnya ya, Rin.
I/O appears on this way,
Makanlah buahnya.
and low ohm needs to appear on drain to source. Because it's AP channel MOSFET, so this high ohm appears on this way, and low ohm
Pancinganku udah rusak.
and low ohm needs to appear on drain to source.
Sabar, coba tak buatin.
Because it's AP channel MOSFET, so this MOSFET is okay too.
Wah, aku tak ada rope.
Here is 1.05
Buat rope dulu
volts
berarti.
PWM of PCH.
Gak ada apa, Rin?
Perform home check
Rope.
on drain
Ini
of
aku
low MOSFET.
mau ini pancingan. Aku ada nih. Mau.
Kan bisa dari
With the help of consumer, low MOSFET
Different.
and PWM.
Iya udah, udah mau. Nih.
7 to 8 ohm is good on this way.
Nah,
Different ohm needs to appear on the other way. Yes, 3 ohm on one
Yay.
way and 7 to 8 ohm on the other way. This is normal too. Only the high MOSFET is left to be checked with
Iya, ada
all
apa itu? Ya,
SEP and
anchor
PWM.
nggak sih?
mau usah ini.
MOSFET are on this choke with DND. Make sure
Ini aku
that
pakai
help
pedal
consumer,
nih, jadi
low MOSFET and
cepet
PWM.
nyampenya.
7 to 8 ohm is good on this way. Different ohm needs to appear on the other way.
Oke.
Menyangkutkan di
Yes, 3 ohm on one way and 7 to 8 ohm on the other way. This is normal too. Only the high MOSFET is left to be checked, which I'll check separately. High ohm appears on this way. It's an N-channel MOSFET, so low ohm needs to appear on source to drain.
Ami, ini udah serem.
So I can
No,
apply
no, 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 no.
Now I need to perform ohm check on plus 3 DSD regulator. I perform ohm check on its input, plus 5 DSD on
aku
this
udah
pin.
ituin anchor.
Oh iya,
Ah,
Around 13 ohm appears.
hilang
This pin is
deh.
output. 13 ohm appears on output.
Yaudah,
aku udah anchor nih, Rin. Kalau mau
It is possible that there is a
menjelajahi
short circuit
lautan.
inside.
Oke.
I perform ohm check on input to output. In analog voltmeters, ohms lower than 3 ohm is suspicious of short circuit. That's why I perform ohm check on the other way as well. This regulator is most probably shorted. I need to remove it and check again. There is another double MOSFET in this block, which is similar to double MOSFET of RAM BCC. This one is double
Ini tidur dulu.
BCC.
Tapi nggak ada ininya. Nggak ada liftnya.
Aku cuma ada lift 2. Bed ada berapa liftnya gitu?
Untuk membuat ini aku butuh 10 jadi 8 lagi.
Iya, kamu kan bisa
Ini aku mau ngambil.
tebang dulu sebentar.
Soalnya ini takut dibunuh sama elang. Elangnya ganas. Tuh kan, aduh kena.
Bor nggak sih?
Iya bor sama elang. What? I can move. Aku nggak bisa bergerak. Wait ya.
Kenapa?
Nggak tahu. Bikin lentera ya beb ya nanti.
Ngapain?
Nggak tahu. Sabar. Keluar dulu dari game. Aku 10 menit lagi udahan ya.
I perform on check on this one too. The upper MOSFET is AP channel MOSFET.
Dan sekarang juga
On this way, because it's
Ya,
AP channel
nanggung.
MOSFET, low ohm appears on drain
Nanggung.
to source. High ohm needs to appear on the other way.
dan sekarang aja Rin.
Kenapa?
Aku mau
This
ke
one is
WC
an
juga ya.
internal MOSFET.
Oh, yaudah.
Low ohm
Oke,
appears on source to drain.
bye-bye.
High ohm needs to appear